Greetings, myself Divesh and Sanjay Kannan are going to present our term project. Our topic is self-healing of smart grid. Now let us see what is smart grid. Delivering electrical power from the generating station to consumption loads is the classical task for the power grid. However, a power grid and any other network infrastructure share some difficulties in operation, control, efficiency and reliability. So the smart grid is obtained. It is defined as a smart grid is an electrical grid that uses a computer-based remote control and automation to deliver electrical power from where it is generated to customers. In order to improve the delivery of electrical power, the continual developments in smart grid technology can be used to make a power distribution system more intelligent, efficient, and secure. Here, why do we need smart grid? Smart grids are not only aligned perfectly with the needs and the demands of our time, they are also predicted to have significant long-lasting effects. This will help to reduce likelihood of blackouts, burnout, and power surges. The technology will also reduce both the costs of energy consumption and production. With its full implementation, smart grids will make renewable power feasible and equip the grid to meet increasing energy demands. More importantly, however, the technology will give consumers near real-time control of their energy bills and facilitate a large-scale electrical vehicle charge. Here, now we are going to see four main blocks of a smart grid. The first one is sensor system. So the smart grid sensor can be used to monitor current transformer, potential transformer, pressure measurement unit, and a smart meter, and so on. In smart grid, it has four parts: a transducer, a microcomputer, a transceiver, and a power source. The transducer generates electrical signal based on phenomena such as power line voltage. The microcomputer processes and stores the sensor output. The transceiver, which can be hardwired or wireless, receives a command from a central computer and transmits data to that computer. The power for each sensor is derived from the electric utility or from a battery. The second one is communication infrastructure. So, electric system that uses information, two-way, cyber secure communication technologies, and computational intelligence in an integrated fashion across the entire spectrum of the energy system from the generation to the end point of the consumption. The third one is control algorithm. It is a type of logic programmed into a controller to analyze the error between a measured value and a set point. This logic helps the controller process field data and decide what to do. The fourth one is uh, actuator system. So it is a component of a machine that is responsible for moving and controlling a mechanism or a system. For example, breaker tripping. So because of either a circuit overloader or a ground fault or a short circuit. So here now we are going to see the modern smart grid should. So here it should detect and address the potential problems, and we need to obtain the input from the measurement through a communication network and identify the problem, and we need to solve it quickly. So it automatically adapts protective system to change the network configuration, and if there is a fault, smart grid should reroute the power flow and change the load patterns. So when we compare with the traditional grid, there is a improvement in reliability and efficiency. So let us see the characteristics of smart grid. Uh, yeah, first one is self healing. So here it minimizes the blackouts because they allow for continuous self assessments that inspect, analyze, and automatically response to the problem. The second one is customer demand motivation. Here, the demand response provides an opportunity for consumers to play a significant role in the operations of the electric grid by reducing or shifting their electricity usage during peak periods in response to time-based rates. The third one is resist attack. Here it minimizes the cyber attack. So the encryption and the filtering of alarms and communications are the technologies which are included. The fourth one is optimization of assets usage. So it refers to activities undertaken to improve the performance and efficiency of electricity transmission and distribution system by grid operators. Now, yeah, this is a main slide. Well, this is a self-healing grid vision. So it is expected to respond the threats, material failure by preventing the spread of disturbances. So we need to identify the problem, and the time response should be very fast so that we can resolve it very fast and losses will be minimized. So now Sanjay will continue the presentation.
So basically, the power system of a smart grid have three main grids in it. The first one is a transmission grid, and the second one is a distribution grid, and the third one is the microgrid. Uh, Now coming to the transmission grid self-healing. So basically, in a transmission grid, we will have a different kind of sensors, signal process, and communication network, not to determine the transmission line parameters. And here we have a genetic algorithm based optimal tension control. This method is used to find the fault position, and here what we do is we insert the previously occurring facts into the algorithm, and based on this the fault location is found. The second one is it's basically a power flow controller, in which what we do is we use a reverse current network instead of an iteration algorithm, and a node analysis method instead of a optimization method. Now coming to distribution grid self-healing. So here what we do is we have a traveling wave system mechanism in which the fault is detected when the measured moving wave is greater than the setting threshold. So and we have another algorithm called an ant colony algorithm, which has been proposed. This algorithm is very fast, and it will react very faster during adverse situation. And we also have a algorithm called a multi-item control system for smart distribution in networks. And here we use fuzzy control algorithms in order to make decision, and this also help us to reconfigure your distribution network and to eliminate voltage irregularities. And finally, we have a microgrid for self-healing. Basically, your microgrid, it plays an important role within the smart grid. So we basically club the microgrid not to get a smart grid. So here we have proposed method which maximize the power flow, and here what we do is we we look for the availability of renewable resources and stored energy to create a microgrid under island conditions, and integrating all these microgrids into a distribution network is useful as it simplifies the implementation of smart grid functions. Now coming to the process of clearing faults, initially it has three stages. One is fault and restoration and clear faults. During the fault, we initially find the fault, and we will try to locate the fault. And after finding the fault, we will isolate the affected area, and we will make sure that this fault is not spread above above the affected area. And the second thing is that we try to impact the affected area, and we use different feeders in order to feed the other nodes in the grid. And finally we clear the fault, and after clearing the fault we stop feeding the loads with the feeder and other subsources, and we feed them with the main source. Now coming to the sensors which are installed in the overhead transmission lines, we have wireless power line sensors which are present in the overhead transmission lines. So they basically sends the measurements to the data collection system. So here, let us take an analogy. Here we have two nodes A and B. There is a fault which is going to happen between these two nodes. Uh, uh, Here, when the fault is encountered, sensor B will indicate a voltage drop, and it will send a message to the controller station, and it will make sure, it will ask for to diagnose the situation. And due to the fault, there is a traveling wave which is created. So the sensor area, it will indicate the voltage drop, and it will send an update to the head controller. So this head controller, it immediately it will isolate the faulted area, and it will send a command to the SD connected to sensor's closest RMU. RMU means ring main unit. So, and at the same time, when the fault area is isolated, here we use a we have a different green source, and this source is used to feed the other loads. And once the fault is cleared, the isolated lines can be restored using the original source, and which must be synchronized with other sources when disconnected using RMUs. Here, so here we have we have total of 5 nodes A, B, C, D, E, which feed different kind of loads, and there is a fault which is occurring between A and B. So what happens is that initially, before fault, this main source is feeding all the loads. When a fault is encountered between A and B, this main source, it will stop feeding all other nodes such as A, D, E, and C. And if we have a green source here, this will feed the other nodes such as C, D, and E after fault. Now coming to the conclusion, so basically we will have a controller system that is designed not to monitor all those fault clearing mechanisms, and what happens is that if a fault occurs, the system will respond naturally to isolate the line by tripping the relay from the main bus to the open the switch. So self-healing protection system can be improved by increasing the number of sensors and the main controllers which is present in the grid. This will improve the reliability and protection of the grid and reduce the cost of power outages and maintenance. And these are the references which we have gone through. Thank you.